I used here formulas. I didn't give a formula for the voltage, but if you know the formula V squared over R, it's no problem to find E from that power. If you have power, power equals V squared over R. What is the V for that power? Anyway, that's the answer. Now, many questions is kind of bonus question, I consider, because they're short, and if you know the concept of M, it's no big deal. Now, what part of the M contains information? Obviously not the carrier, because it's just a carrier. Side waves. Either two of them or one, doesn't matter. Side waves. If you put here answer just one word, side band, voila. Now, advantage and limitation of the crystal oscillator. Advantage, very stable and accurate, precise. What is the limitation? They only oscillate in the high region, megahertz, gigahertz. They not oscillate in kilohertz, where actually our all radio frequency sits. That's the limitation. But you already know how to use oscillator and make it low frequency. Remember? PLL frequency synthesizer. We can plug gigahertz, put Q divider, and it will give you kilohertz. Stable, fixed kilohertz, because it's based on the reference of oscillator. Okay, why it's possible to use one sideband? Because both of them have an info. We can choose either this or this, and that's the concept behind the single sideband with suppressed carrier. If you did answer this, you already got around 15. First page, around 15. Now, again, this is kind of same question from a previous quiz. You need to recognize what's the circuit, and this is Colpitts oscillator because it has capacitors and a voltage divider with one inductor. What is the function of it? Oscillate, provide the frequency. It's a part of oscillation, yeah? And function oscillation that uses that portion as a 180 degree to provide oscillation. Okay. Okay. Tricky, but again, if you did understood what is the AM and why we need modulation, doesn't matter, AM, FM. Why we need modulate the signal? Because all of these channels, they use the same range of frequency. It's a voice or it's a music. It sits in this range. If you want to use all these different channels with the same range, combine them and send, it will just cacamania of different sounds together because in the same range. We have to separate them. How we separate them? With the carrier, with the different carriers. Same range, different carriers. Now we can make a channels. And for this you will answer just one channel because we don't have any carriers. And for this as many as number of the carriers. Right? That's the most important reason why we modulate signal. To translate all these same things in different channels, different carriers, and then you tune to the different carriers and you choose whatever channel. Okay. Low level, high level. Again, I expect to see that blocks. For the high level, you have just one block and combine both modulator and class C amplifier. It modulates, nonlinear, and amplifies. That's the antenna. That's the low level description. Now, low level. Low level, your modulator is not providing high energy, high power signal. And after this, next block, it will amplify. Linear, nonlinear, nonlinear. That's the answer. If you use word linear, non-linear, high power, low power, it's nothing to do with high frequency, low frequency. It's all about power. Okay, next question. Someone was asking question, what is IF? IF, it's an intermediate frequency. Everything we translate into the receiver to the IF. We have different carriers at the input, but when we translate all these different carriers to this one carrier, only one, everything works with this one frequency. Easy to design. We don't need to have huge bandwidth from all these channels. Just bandwidth for this 455 plus information manipulation. And all amplifiers, resonators, mixers, they all work with the same frequency. That's the only reason. IF, intermediate. And we have image frequency. Image frequency is something created by the mixer, and we don't want them. They are these images, we don't like them. That's why we have the first IF conversion with high frequency, because image well out of the standard range of the frequency. But anyway, if you have a AM signal, that's the AM signal, that's the RF signal, that's what comes to the antenna, that's the carrier itself, desired signal, and we have LO of our receiver, that frequency. What will be IF? This minus this. That's my IF. Okay, what is my image which I don't like? Image will be created from RF and double IF. RF7 and double IF. That's the image, 16 megahertz. Well out of standard range. But anyway, please remember this. In 2 months probably you will forget this, but exam will come, and again, exam will ask you something about AM. Make sure you remember this, or study this. They have, unfortunately, two same letters, IF, intermediate frequency and image frequency, but the meaning different. Mostly when you see IF, it's about intermediate frequency. Image will have word image frequency or something. Okay. Carrier power cannot use a measure form, obviously, because what is a DSB-SC? DSB-SC, it's a double sideband suppressed carrier. There is no carrier. What is a SSB-CS? Single sideband suppressed carrier. There is no carrier. Carrier cannot be used. What can be used? PEP. Peak envelope power. I didn't ask you to calculate this, but it's easy. Just take a peak of your sideband and use formula power. Okay, important parameters, sensitivity, selectivity. I hope all of you answer them properly, because selectivity itself tells what to select the channel and block whatever unwanted. Select wanted and block unwanted. Selectivity. Sensitivity. Being able to pick up the signal. Signal can be weak, and our amplifier have to be enough strong to amplify this and reconstruct. Selectivity, sensitivity. Power of the signal and position in the frequency domain. What is the major advantage of the SSB to the AM? Of course, advantage, we don't wasting power on the carrier. SSB, just one frequency, and that frequency conveys already information. And we can use all our available for that frequency. More efficient. More power efficient because power is not wasted on the carrier. And we know that 2/3 of the power actually goes for the carrier. Congratulations. Okay, what is this? What it produces? Frequency. Frequency synthesizer. Oh, frequency generators. But that's more proper because we can control the frequency by this divide by n, not plus by n. You ask me what is divide or plus? You should know definition of a synthesizer. It is divided, programmable counter. Counter always divides. Whatever it is, BTS, that part of NFC divider, yeah? I will count. Divide. Anyway, we have 5K, and it's synthesizer, that means it's locked. If it's locked, it's very easy. It has same frequency. If I have 5K megahertz, that means when it's already generated, it has the same frequency here. Same, 5, 5. Now, if it's 20 and it is 5, what is the n? High mathematics. Yeah, you have to take this integral natural number logarithm of distance to the Mars and divide by your student number. And the answer will be 4. And answer will be 5. Any question? Anytime you have a problem, you don't know answer, just write down the student number. Maybe it will be correct. You never know.
Also, student number or just one digit?
Sorry, but I tested you again for the ECR 255 because it's a part of the course. And here you have a tank, resonant, parallel circuit with all components given. Only you need to go to your last page and use proper formulas to calculate. And I actually noticed one of you were using formula for the cut-off frequency, not the resonant. The resonant frequency is 2 pi LC, not 2 pi RL or something else, RC. That one. You put the numbers in it, you'll get your resonant frequency, What is the bandwidth? What is the Q? And again, using all these formulas. Yeah? Bigger than 10, we can use that formula. And formula was there. 5K, what is the bandwidth? Again, formula. And actually, I suspect that some of it will be correct. Maybe you got confused here and here.
But how about C?
Yeah.
The union for the
C?
C.
Impedance.
Impedance.
Yeah, impedance, yeah. It
That
must
is
be.
it?
Yeah, the
Yeah.
The
That is
union
it.
Union.
must be
The
5
union.
kilo
Ah.
Yeah,
ohms.
the unit.
Minus 5. No.
Give us.
plus
min-
5.
minus 2. Yeah, of course it have to be ohms.
Ah.
Kilo ohms. I just was going,
My bad.
yeah, ohms. Obviously, ohms. What is the bandwidth? Again, you have a Q, you have your resonant frequency, you put it here, and you got the unit. I have to.
No.
We need to add 5 on.
Okay, now, that was kind of simple but tricky. First of all, you should remember which part of this is the carrier, which part of this is intelligence. And this is carrier part, and this is intelligence. That part. And you already have here frequency given, omega c. This is when you have this in form. Again, sorry, but it's from ECR 255 question. Yeah? This is omega, this is omega. Omega equals 2 pi f. From this 2 pi f, you can find your frequency. Just put that number, divide by 2 pi, 6 megahertz. Yeah? Same thing, put this number, 2 pi, 12 kilohertz. If you got these numbers, good. If you suddenly stuck here because you have no idea meaning of this, sorry, blame your ECR performance. Okay, now, that was easy. Now with amplitudes, because here I have these different numbers, 12, 4. What I did, I just rearranged this. I brought this back to the original format. Instead of 12, I got here 1. It means 12 jumped out of the brackets. And all this 4 changed. Now it's a pure AM description, which gives you everything. It gives the amplitude of the carrier, peak. It gives my modulation index here, because the formula is 1 plus M1 modulation signal multiplied by the carrier with its peak. Right? Some of you had a different way of doing this. Actually, using that that number as the peak and then dividing it by this, saying, okay, this is my. But if you got right answer, doesn't matter how you get. That's the right answer. Straight through. Okay, complete. And guys, be survivors. Always use available information. Some of you, if you don't have any idea, but our receivers always having something selector, local, and mixer. When you go to the question, that one, yes, you have this here. You can actually, look in this diagram, can use this and go back and actually reconstruct things back to this. But anyway, what was missing here before we, because it says I am receiving intermediate frequency. That means have to be mixer producing that frequency. What mixer collects? Mixer collects LO and mixer collects preselected channel. How you preselect this channel? You tune it. And tuning is ganged. That means whatever LO and whatever preselected, they have together bank of this tuning capacitors or whatever variable used to tune to the different frequencies. That's really my game. Now, AGC. What is AGC? AGC checks the level of your DC output, and if it fluctuates up or down, it provides negative feedback. If that signal too low, it increases the gain. If it's too high, it decreases the gain. That's the automatic. Believe me, it's a G. AGC. Automatic gain control. If you send the same sinusoid with the same amplitude, constant, but your receiver produces up and downs, that compensated up and downs, and eventually you will have here stable, same amplitude, amplified and given to whatever is the transducer, whatever is your role. Okay, from time domain to frequency domain. Easiest question, because I provide you with everything. You have full period of it. You can find out about frequency of the intelligence. You got AC, unmodulated carrier. You got AE, amplitude of your intelligence. Everything is there. You have time settings, you have voltage settings, 1 volt, easy. Whatever is the divisions, same is this, because it's multiplied just 1. Simple as impossible. Now, from the settings, we got peak for the carrier, we got peak for the information. We have both of them. Can you find modulation index? No problem. If you, for some reason, use maximum, minimum, doesn't matter. You will get the same modulation index. Okay, that's the model. Now, what is the period of it? 1, 2, 3, 4, 5. 1, 2, 3, 4. 4 by 50, 200 meg, 5 kilohertz. Right?
Yeah.
I know it's a 5. Now I know will be plus 5, minus 5. What is the carrier? I think I gave you carrier. 10 times of the intelligence. Yeah? Once you found this, carrier will be 10 times. 50 kilohertz. Done. I got all information. Now I need to use this information to build that structure, to grow these two trees. Where located will be that trees? Okay, I need to find out what is the size of my windows. And that's the size of my window. 44 start, 64 finish. 64 minus 44, 20 by 10, that means each scale now 2 kilohertz per division. Simple. Now, I can place my 50K here now, because I know my carrier, okay? That's the position according to my scaling. 50k, then 50k plus 5k, 50k minus 5k. Done. Location is found. How tall will be my trees? Okay. What is the power of it? From the carriers, I will get the powers. From the powers, milliwatts, I will get my decibel amps, 14.6, 6.9 decibel amp. Now, let's see that scale. When it starts, reference, plus 20. This is plus 20. What is my step? What is the scale? 5 divisions. That means 20, 15, 10, 5, 0, minus 5, 10 goes down. Power goes down and decibel decreases. At that 0, it's 1 milliwatt. 1 milliwatt always produces decibel 0. It's your ref kind of always you can check. If it's less than 1 milliwatt, it will be negative. If it's more than 1 milliwatt, it will be positive. Okay, now we need to find 14.6. Okay, that's 15, that's 10, somewhere here. Okay, that's 14.6. Again, plus minus little bit, half millimeter, no problem, because human eyes, accuracy, we cannot have here 10 significant digits because it just scream. Okay, that's the 5K. Okay, for the sidebands, 6.9, approximately 7. And we're looking for something here, which is 5. And somewhere here we get our 7. That's it. Yes.
Professor, my EC is 1.5 volts. Is that okay?
1.5?
Yeah.
1.7. Because it's
hard to read. So it's okay.
one is hard to read. This is one division. It's not in the middle. This is not in the middle. Look here, smaller, bigger. Do you see it?
Yeah, but the EI is a little bit more than 1, right? The intelligence?
Yeah, this is one division, right?
Yeah.
Which is 1 volt. Plus something.
Something.
That something is not in the middle.
Yeah.
It means it's a little bit less than
Yeah.
middle.
It's
1.5 will be in the middle. Right?
No, what I mean, AI, 1, it says we are for 1. Your
AI, 1. Oh, I used one
Yeah,
division.
yeah.
Where's my 1.3?
1.2?
Okay. That's my fault, by the way. Because oh, I know what I did. I wipe it. I wiped it because I put here 1.7. I wiped it and then I put here right one,
Oh.
1.4. And I didn't write 4 here because I used this whitewash. Because I wrote here 1.7, then I realized it's not 1. It's 1 point less than 5, and I used here correct in calculations. Calculation is correct, but I didn't actually. I waited when it will be dry, did my whitewash, and then forgot to put 4.
Oh, I see, sir. I write on the EC is 1.75 and the EI is 1.25.
See, I give you everything. I give you this dash line. Just look at this dash line. They tell everything. You don't need to guess. Okay, when your mistake is smaller one, but concept is there, no problem.
Oh, okay.
Just next time be aware that using your eyes properly. Okay, and it's the last question. The last question. Again, simple as it can be. Okay, there is a single frequency of SSB. Already I'm giving you answer for the, give the name of the device. Yeah? If I say you have that at antenna, and it's obviously not a transmitter, if it's not transmitter, what it is? Receiver. And what it receives? SSB, single sideband. And it's your carrier is 1 megahertz. What it is? Low or upper?
Low.
Lower. What is your intelligence? 1 megahertz minus this. Yeah? I already, from this 1, 2, I already got 3 things. I know the carrier, I know that it's single send and receiver, and what is my intelligence. Okay? That was originally modulated as a transmitter and sent as a SSB at that frequency. Just that frequency. No carrier, no upper, just one frequency. I already know that here sits this 990. And I know that this is my SSB receiver. I can start from here and move, or I can start from here, doesn't matter. I started from here. Now, this is IF amplifier. That baby deals with 455. Intermediate. How to do 455? And if I know that it's 990 here, and I know 445 here, 455, what frequency? Again, just simple arithmetic. Now, at preselector, okay, at antenna I have that frequency. Preselector, what does preselector? It chooses entire AM bandwidth because it can be universal. We need to use this either for the low or the high. That's why it chooses all AM bandwidth. If it receives high, it will go there. If it receives low, low will go there. Preselector have to be tuned not just to one frequency, but entire AM bandwidth. Entire that thing. That's the bandwidth. If I'm receiving this, I will receive this. If I receive this, I will receive this. Either. That's the width of bandwidth of the preselector. Of course, it will always only one, either lower or higher, and no carrier. Okay, and obviously after we made the bandwidth like this, that baby will be passive, and that baby will have that signal here. Now, what will be the local? My local will be to produce